Welcome, my dear learners, to another exciting episode on this web channel. In today's lesson, we want to look at the nature of roots of a quadratic equation. If you have not subscribed to the channel, kindly do so for more episodes to come. When we talk about the nature of roots of a quadratic equation, we are referring to the type of solution that the quadratic equation is going to have when you solve it. Is the solution or the roots going to be a real root or a complex root? When we talk about the roots, we are referring to the answers or the solutions that we obtain whenever we solve a quadratic equation. Now we know that whenever we solve a quadratic equation, we obtain two roots. So when you have a quadratic equation of this form, the solutions or the root of this quadratic equation is going to be what? Two roots. Now we can solve this using any of the methods that we have already discussed in our previous lesson. We can use the factorization approach to solve this. We can use the quadratic formula to solve this. We can also use the completing of squares to solve this. All of these methods is going to give us the same answer. So when you solve this quadratic equation, you are going to have your x to be equal to -1 or your x to be equal to +3. So this -1 and then 3 is what refers to as what? The roots of the quadratic equation, which we normally call it the solution or the answers to the quadratic equation. In this lesson, we want to determine whether these roots is going to be a real root, in other words, a real number that can be plotted on the x-axis, or a complex root. This is what we want to do or look at in this very lesson. Now let's look at the curve of a quadratic function. So these are x and then y plane. We know that whenever we sketch a quadratic curve, it is either going to cut the x-axis at two different points, or cut the x-axis at only one point, or sometimes hang in the air above or below the x-axis. The point where the curve intersects or cuts the x-axis becomes the root of the quadratic equation, because at that very point our y-axis becomes 0. So when you have a curve of this very form, so you can see that this curve is intersecting the x-axis at two different points. So at -1 and then +3. The point where this curve intersects the x-axis becomes the root of the quadratic equation. So the root of this quadratic equation is what? X is equal to -1 and then x is equal to what? +3. Now these roots, are they real or complex roots? Are they real numbers or complex numbers? They are real numbers because they can be plotted on the x and y plane. So when the curve intersects the x-axis at two different points, then the root of this quadratic equation is going to be what? Real and then distinct or different root. So when we look at these two roots of the quadratic curve, -1 is different from what? +3. So they are real numbers, but they are what? Different. So the root of this quadratic curve is real and then distinct. Now let's look at another type of a quadratic curve. When you have a quadratic curve which touches the x-axis at only one point, so let's look at this curve. So this is another quadratic curve. We can see that this quadratic curve is touching the x-axis, or it is cutting the x-axis at only one point. And the point of its intersection with the x-axis is at point 4. Therefore, point 4 becomes what? The root of the quadratic equation. So the root of this quadratic equation is at x is equal to 4. Now this 4, which is the root of this quadratic curve, is it a real number or a complex number? So you can say that this curve, the root is what? A real number, but it is repeating. So we have a repeated root. You can have a quadratic curve which will not intersect or cut the x-axis, but rather it's going to either hang in the air above the x-axis or below the x-axis. Since these two curves does not intersect the x-axis, the root of this quadratic equation is not going to be real, but rather it's going to be what? A complex root. So these are the types of roots that we have. We have real and then distinct roots, real and then repeated roots, and then complex roots. When the curve intersects the x-axis at two different points, then we are going to have real and then distinct roots. When the curve intersects the x-axis at only one point, we are going to get real but repeated roots. And when the curve does not intersect the x-axis but hang below or above the x-axis, we are going to have a complex or imaginary root. Now the question is, do we always have to sketch these curves before we can determine the nature of root of these quadratic equations? The answer is no. In that case, we are going to make use of what we call the discriminant. The discriminant can be used to determine the nature of the root of a quadratic equation. From the quadratic formula which is given us, where a, b, and c are all real numbers, the expression under the radical sign is what we refer to as what? The discriminant. So under the radical sign or the root sign, we have this b squared minus 4ac. This is called the discriminant because it determines the nature of the root, or it can be used to determine the nature of the root. Now, what does this discriminant say? So this discriminant says that when it is greater than 0, so when the discriminant is greater than 0, then the root of the quadratic equation is going to be real, and then distinct. When the discriminant is greater than 0, then the root of the quadratic equation is going to be a real number but different numbers. Also, when the discriminant, which is given as b squared minus 4ac, is equal to 0, then the root or the answers to the quadratic equation is going to be a real number and then repeated roots. And lastly, when the discriminant, which is given as b squared minus 4ac, is less than 0, then we are going to get no real root, but rather a complex or imaginary root. So why are we saying that the expression, this one, under the radical sign, determines the nature of the root? Let's start with the first one. We are saying that if the expression under the radical sign is greater than 0, we are getting real and then distinct roots. Real numbers by different numbers. That is when the expression under the radical sign is greater than 0. If it is greater than 0, then it means that we are going to have what? Positive numbers such as 1, 2, 3, 4, 5 up to infinity. So let's take it that the expression under the radical sign is giving us positive 4. Now positive 4 we are going to get 2. These are all real numbers. When we add them, we are going to get a real number. When we subtract them, we are going to get real numbers. But they are going to be different because of the plus or minus. So we are going to get real numbers, but different numbers because of the plus or minus. Now we are also saying that when the expression under the radical sign is equal to 0, so when the expression under the radical sign is equal to 0, then we are going to get real numbers by the same number. Real numbers by repeated roots. Now we know that root of 0 is still going to give us 0. So 0 plus or minus these numbers is going to give us the same number. 0 plus this number will give us the same number. 0 minus this number will give us the same number. So that number is also a real number. So that is why we are saying that we are going to get real numbers, but it is going to repeat, because 0 plus or minus these numbers is going to give us the same number. I believe you are following me. Now let's look at the last one. We are saying that when the expression under the radical sign is less than 0, is less than 0 means we are going to get a negative number. So negative numbers can be -1, -2, -3, up to where? Infinity. So let's say -1. And we know that the roots of a negative number will give you a complex number or an imaginary number. So an imaginary number plus or minus a real number will give you an imaginary number. So this is why we are saying that the expression under the radical sign will determine the nature of the roots. Now that you understand this concept, let's determine the nature of the root of the following quadratic equation. So we want to describe or determine the nature of these quadratic equations, and in doing that we are going to make use of what? The discriminant, which is giving us b squared minus what? 4ac. So let's start with the first one, I. So from here, our a is equal to what? 2, our b is equal to -1, and then our c is equal to -1. We are just going to substitute this into the discriminant to determine whether it is going to be greater than 0, equal to 0, or less than 0. So from here, just substitute this into the discriminant. Our b is equal to -1, all squared, we have minus. Our a is what? 2, our c is -1. This is going to give us 1, and then we have plus what? 8, and this is going to give us what? 9. And we can see that 9 is what? Greater than what? 0. So it means that the root of this quadratic equation is going to be what? Real and then distinct root, since the discriminant, which is 9, is greater than what? 0. You can point this equation into your calculator to see if it's going to give you two real and then different roots. Let's look at example 2. We have our a is equal to 3, our b is equal to -2, and then our c is equal to 4. So we are just going to substitute this into the discriminant. So we have -2 all squared minus 4. Our a is what? 3. Our c is what? 4. This is going to give us 4. This is going to give us what? 48. So we are going to have what? -44. And we can see that -44 is what? Is less than 0. And whenever the discriminant is less than 0, we are going to have a complex root. So the nature of root of this quadratic equation is going to be what? A complex root. As I said earlier on, you can always point it on your calculator to see whether you are going to get a complex root or not. Let's look at the last one. So with the third one, our a is equal to 4, b is equal to minus 12, and then c is equal to 9. So we are going to substitute this into the discriminant. So we have b squared, so we have minus 12 all squared minus 4. Our a is what? 4 times c, which is 9. This will give us 144. This will also give us 144. And we are getting what? 0. And we are saying that if the discriminant is equal to 0, then the nature of root of this quadratic equation is going to be what? Real, and then repeated root. As easy as that. This brings us to the end of today's lesson. If you have not subscribed to the channel, kindly do so for more interesting episodes. See you tomorrow. Bye bye.